Alright, grade 7, so we're going to be tying everything together this week. We're going to look at the three different types of heat transfer in a bit more detail. So we're going to look at conduction, convection, radiation. I'm going to summarize everything for you so you don't have to stress. It seems like a lot of work, but it is not that hectic. Alright, so let's just quickly look through the textbook, see exactly what you need to be doing, and then I'm going to summarize it for you. So page 115, when we talk about the transfer of heat via conduction, I want you to please read through these two small paragraphs. Okay, don't worry about doing the practical activities because there is a link to them in your schedules. You can watch those videos. If you're back in class, I'll show you them in class. But this is just an example of the conduction of heat and which materials conduct better and which materials don't conduct heat or electricity that well. I'll explain why metal is such a good conductor of heat now. Okay, and then we'll look at what insulators are as them being the exact opposite of a conductor. Once you've read through that, we move on to convection. Alright, so with convection, again, it's a small little piece that you have to read through here. I'll explain to you how convectional current works, and you'll complete challenge activity 2. And then lastly, heat transfer via radiation. It's a small paragraph to read through. Okay, and again, there's an animation for you to look through, and then you'll be able to answer challenge activity 3. So please, grade 7s, you need to go and watch those animation links in the videos, the video links that are in the schedules, right? It's one animation that explains the conduction, convection, and radiation a bit more in detail using an animation, right? And then there's also a link to these experiments. So you'll see with convection, they use food coloring and water, and it shows you the current as heat is added. With radiation, there's an animation that shows you, and also make I'll refer to things that you've experienced in your daily lives. And then conduction is it shows you which materials conduct better. Okay, so I'm going to put the textbook away, and I just want you to focus on what I say with regards to the three different types of heat transfer. So we break it down into the three different types. So conduction, convection, and radiation. Right, so conduction stipulates that heat is transferred from one side of an object to another side of an object. So it needs to be a solid object that is constantly in contact. So just to give an example, we have a piece of wire. Right, now with the piece of wire, it's a solid object, and because it's a solid object, the particles are tightly packed together. So when I add heat on this side of the object, alright, so my conductive wire, the heat then transfers from one side of the piece of wire to the other side of the piece of wire. Now why this happens is the particles start to move rapidly and vigorously, and then as they move faster, the heat transfers from one side to the other side. Right, this is heat transfer via conduction. The reason why metal is such a good conductor of heat and electricity is because it is very dense and the particles are packed very closely together. Okay, wood is also a solid object. So if this was wood, the particles aren't as closely packed together compared to metal, because metal will be right on top of one another. This will be very, very dense compared to wood. So wood would still eventually conduct a little bit of heat, but it's never going to conduct the same amount of heat because the heat will dissipate off the wood before it even gets to your hand. Whereas if you're holding a piece of metal on this side, very quickly the heat's going to transfer and it will eventually start to burn you. Okay, and that's where insulators come in. So an insulator is the exact opposite of a conductor. Alright, so a conductor allows electricity to flow from one side to the other, whereas an insulator prevents electricity from flowing from one side to another. Right, so examples of insulators would be the plastic around metal cables that protects us from getting electrical shocks or electrocuted. Okay, another example would be go look in your kitchen on top of your pot lids. I remember my grandmother used to have a cooking set with the pots where you had to use a dish towel or something to pick up the lid of the pot because it didn't have an insulator on top of the handle. It was metal on top of the handle, so you would burn if you didn't use, say, an oven mitt or something to lift the lid off. Now this is very old pots, right? All the new stuff today, they've all got like a plastic type handle. So if you go look inside your kitchens, you'll see the frying pans will have plastic handles on them, and this is an insulator, a form of an insulator, so that you do not get burnt, because you don't want to be frying something and then you come and grab the pan, and if the handle's also made of metal, the heat's going to then transfer across the pan or into the handle. So if this is the pan, the heat's eventually going to move up the handle, and if you don't have that insulator wrapped around, you would burn. Alright, so just go have a look in your kitchen. You'll see all the lids on the pots probably have an insulator for you to open up the pot. Alright, as well as insulators on the handles, so you're able to lift the pot without burning. Okay, so that's conduction. Convection, on the other hand, is heat that moves through gas or a liquid. Alright, so an example will be you are standing next to a fire, alright, and you can feel the heat against your skin. So now this is a small amount of air over here. It's not a lot of air, and the reason why I'm saying it's a small amount of air is it'll make sense when we talk about radiation. This is referred to as convection. So convection is a transfer of heat through a small gap of air, alright, or a small amount of air, or through a liquid. So there's two examples. Let's say we had two rooms, okay, and on this side I'm just going to draw a pot to show you how the convectional currents work. So if you had two rooms, if you want to heat the room up, you want to put a heater at the bottom of the room. The reason why you want the heater at the bottom of the room is because hot air rises. Okay, and that's a convectional current. As the hot air rises, it will eventually start to cool down, and as it cools, it comes back down towards the ground, and then the heater heats it up again, and it's a constant cycle. Okay, so this is a convectional current to generate heat. So you'll see your heaters, fireplaces, etc., usually at the bottom on the ground. You do, however, get air cons. So when you want to cool the room down, you're going to use an air con, and I do know that air cons sometimes have a heat function, but I'll explain that just now. If you have air cons at home, you can go play around with this setting and you can see what I'm talking about. But firstly, if you want to cool the room down, it's going to pump the air out into the room, and because cool air is denser than your hot air, it will sink. Alright, and as it sinks again, it will start heating up, and then if it rises, it will hit the aircon again, and the aircon will cool it down, and this convectional current will cool the room down. You'll notice if you have got an aircon at home and you put it on the heat setting, the little shutters or the fins on the aircon is going to point and tilt downward, and then it's going to force the hot air down towards the ground because of the convectional current, and therefore it will heat up the room a bit better than just pumping the hot air out into the top of the room and it stays up closer to the ceiling. Alright, with the pot, again, if you add a heat source, either a fire or a stove plate, you're going to have the hot air, the hot liquid rising, and then it will start cooling and coming back down. So when you watch that video in the schedule that I've linked into the schedule, you'll see what I'm talking about. They put food coloring into the pot, and as they heat up the pot, then it literally, you'll see the food coloring rise and then fall down as it cools down. So these are your convectional currents. Alright, and it ties into convection. Please remember, convection is heat transfer through a gap, alright, or space, through a liquid or a gas. The last one being radiation. Don't confuse radiation now with convection. Radiation is also heat that travels through space, but a large amount of space. So if you have the sun, right, and we have the earth, it is radiation that heats up the earth, but it's able to travel over very long distances in the form of ultraviolet rays, right, or microwaves, etc. This is a form of radiation. Okay. Somewhat similar to traveling across a small space, but over a large scale using ultraviolet rays or microwaves, etc. Okay, a practical example, everyday example of heat transfer via radiation. Those of your parents who have, say, a darker colored car, say a dark blue or black, etc. car, will heat up a lot more in the sun, all right, compared to a white car, which will reflect more of the heat, or it won't absorb as much of the heat. All right, so that's just going to tie into challenge activity 3, and please remember that. So quickly to recap everything: conduction, heat transfer via a solid object that is able to conduct heat. They have to be touching, or heat or electricity. They have to be touching in order for the heat or electricity to transfer. An insulator is the direct opposite of a conductor, right, and therefore it protects us from getting burnt or electrocuted. Convection is a transfer of heat through liquid or gas in a small space. Right, and then we have convectional currents as hot air rises, right, or hot water rises and cool air will sink, and the same thing with cool water will sink. And then lastly, radiation is heat transfer over a over a very far distance, is traveling from the sun, right, in the form of ultraviolet rays, making its way to Earth. Okay, and that is the transfer of heat via radiation. Right, great students, please, I need you just to get cracking on those two activities. Watch the video links, it will explain this all to you in more detail as well. If you don't understand this 100%, the links will hopefully help you out a bit more.